Hello everyone and welcome back to my channel. Are you tired of very generic Docker interview questions that barely scratch the surface? Today we will be diving deep into real world Docker scenarios that test your practical skills. The kind that will truly help separate experts from the rest of the group. So whether you're preparing for a DevOps role or looking to upskill, this video will help you master Docker like never before. Once again, before I start off with the session, please don't forget to hit that subscribe button. Now, before we jump into the questions, let's talk about why advanced Docker matters. So Docker is more than just a tool. It is a DevOps game changer. So it is used in CI/CD, microservices, and even in production orchestration. So in this particular video, we will cover advanced interview questions with real scenarios involving networking, security, image optimization, and more. So let's get started with this. The first question we have is, how do multi-stage builds optimize Docker images? So multi-stage builds mainly help you to optimize your Docker images. And how it does this? It does this by allowing you to use multiple from statements in your Docker file. So generally, we have the from instruction. Now to optimize your image, we can make use of this multiple from instructions in a Docker file. This way, you can build your application in one stage with all your dependencies or the tools that are needed for building the package, and then copy only the necessary artifacts like your binaries or the final compiled files into a clean, minimal final image. Now, this will dramatically reduce the image size, improve the security by excluding all the build tools that are not needed, and leads to faster deployments of your application. So, let's see an example for this. So here, this is an example without using the multi-stage build. So here you can see I'm using only one from instruction. So I'm using Golang. I'm setting my work directory, I'm copying my packages, and then I'm building the package, and then finally I'm running that script. So let me copy this, and let's go to our, let me check this Docker file. Okay, let's rename this to test, and let's create a new Docker file for our example. And this is what we have. So let me save this and let's build this image. So we'll say docker build -t, and oh sorry, I need to give a name. Okay, so this created our image, and if you look at our images, you can see here this is close to 1 GB in size, right? Because this includes the full Go compiler and also the necessary tooling. Now, this is not ideal because build tools are present in this from a security perspective, and also it is not very efficient for your CI/CD. So this is where we can optimize our image by making use of your multi-stage build. So let's see an example for how we can use the multi-stage build. So here is an example of your multi-stage build. So we're using multiple from instructions. So in the first stage, we are building the binary. So we're using Golang as a builder. We are setting the directory, we are copying the packages, and we are building it. And then in the next stage, we are only copying the binaries, right? We don't need the full compiler, we just need the binaries. And then we are using a very minimal image, which is the Alpine image, and then we are deploying our application. So let me copy that, and let's go back here. Let me delete this, and we'll create a new one, and let's run this again. So docker build -t demo, and this will also build an image, but now the image will be more optimized because we are using a multi-stage build. So let's wait for this image to complete. Okay, so now let's look at the size of the image, and you can see it is hardly 20 MB because this only includes the final binary and it uses Alpine as the base image. And from a security perspective, there's no Go compiler or source code in the final image, and this can help you to improve the performance because the pull will be faster, and deployment time will be also much lesser compared to deploying close to 1 GB package. So that's basically how you can optimize your Docker images by making use of your multi-stage builds. The next question we have is, a container can't reach the internet. What do you do? So for this, we will need to identify and fix why a Docker container cannot access the internet, which is often necessary for pulling the packages, calling APIs, or for general outbound traffic. So the first thing that you can do is you can check if the host itself can access the internet. So ensure that the host and not the container, whether the issue is with the container or with the host. So first, check whether the host can access the internet. So for that, you can do a ping. So ping 8.8.8.8, or you can do a ping to google.com. So you can say I'm getting the response. Likewise, you can do a ping to google.com as well. Now this will tell you whether the host machine has internet access or not. So I'm getting the response, that means I have the access. Now if the host machine itself can't reach the internet, then the issue is outside of Docker. Like it could be a firewall issue, a VPN issue, or DNS issue, could be anything. Now let's say in our case the host machine internet is working fine. The next step would be to check the connectivity from the container. So for this, we can start a new container, and let's say we will use busybox, and let's do an SSH. Okay, so there's the container. So let's connect to this. Okay, so we are inside the container, and again do the same thing. Try pinging Google or 8.8.8. So ping 8.8.8.8. So I'm getting the response. Likewise, you can do a ping google.com. So this will tell whether the container is having internet issue or not. Now, if neither work, that means there's some network routing issue. Then you can check for Docker network configuration. So, you can basically inspect your container ID, check the network that your container is using. So let me exit from here, and these are the containers that we are running. So let's inspect this container, and we are looking for the information which is network. Okay, so here you can see what network it is using, and you can validate whether your container is using the right network or not. So by default your network uses the bridge network, and make sure it is set up correctly. So Docker network ls. So bridge network is what we have, and you can do an inspect. So Docker network inspect bridge, and this is the network we have. So you can see the network ID, and it is matching. So that's basically it is using the bridge network. The other thing that you can do is you can try restarting your Docker. So this will reset the IP tables, bridge network, DNS. So sometimes the Docker's networking stack can break after the system restarts or VPN outages. So you can try restarting the Docker. Then you can also check for any firewalls or IP table rules. So if your firewall is blocking the traffic, so you can do a IP tables to check. Oh, sorry, there's a typo. So let me change this. Okay, so you can check the firewall rules as well, whether it is blocking any traffic or not. There are a few more things that you can check, like you can confirm the DNS settings, you can check proxy or VPN settings, and if there is an issue, you can configure Docker with proxy as well. So these are some of the steps that you can do to troubleshoot why your container is not able to connect to the internet. The next question we have is, what are the risks of running containers as root? Now by default, containers often run the processes as the root user. While this user is isolated inside the container, it still poses significant security risks, especially if a container is compromised or misconfigured. Now, the key risks of running containers as root includes privilege escalation to host. All right. So, if someone gets access to your containers, they may get a privilege escalation to the host machine. If there's a vulnerability in the container runtime, like Docker or Containerd, and the process is running as root, an attacker could break out of the container and execute the code on the host machine as a root user. And this could lead to complete system compromise. All right. The other issue you can see is accidental access to sensitive host resources. So if the container mounts a host volume, the root user inside the container can modify Docker on the host machine, read or write sensitive host files, change permissions on binaries as well. The other risk you can see is misuse of capabilities. So the root user inside a container retains Linux capabilities like netadmin, sysadmin, etc. So unless you're explicitly dropping it. Now these can be exploited to manipulate network interfaces, mount file systems, and interfere with kernel level operations. So it can also become harder to enforce least privileges. So security principle of least privilege is violated. So even simple applications that don't need elevated privileges are running with full root power, making them more dangerous if exploited. And the other risk you can see is compliance and auditing failures. So security policies recommend avoiding root in your containers. So running as a root may lead to audit failures in regulated environments. Now, how do you mitigate this risk? So the recommended approach is to use non-root users in your Docker file. So whenever you're building your Docker file, it is recommended to use non-root user. So in my case, all these instructions are getting executed as root users by default. So how do you execute this as a non-root user? So what you can do is, for any step that you don't want to execute as a root user, like for example, let's say starting from here, I want all the instructions to be executed as a non-root user. So I can make use of this user instruction. Now before that, what we will do is, let's say we will add group here, and let's call this as app group, and then we will add a user, and the name of the user would be, let's say, app user, and we want to add that user to the app group. So we are creating a user here, and then we will switch to that user. So we'll use the user instruction and then the name of the user. Now all the subsequent instructions from right after this will get executed as this user. So that's how we can make sure we are not running any instructions in the container as a root user. You can also make sure that the containers don't default to root. So for that, you can use this user 1000:1000. The other option you have is you can also drop the Linux capabilities. All right, so you can limit what the container is allowed to do. So you can do this docker run, and then you can use this -cap, which is your capability, and then I want to drop. So what do you want to do? I want to drop all, and then the name of the image. So this will drop all the capabilities inside the container. Now this is one option, or you can also whitelist the necessary capabilities only. Like for example, so let's say cap drop all, and then we can say cap add, and then the capabilities that you want to allow. So net bind service, and then the name of the image. So basically I'm only allowing this capability, and all the other capabilities I am not allowing. So you can also run containers with security profiles to sandbox processes. And if you're running in Kubernetes, use pod security context to enforce non-root execution. Alright, so basically the recommendation is don't use non-root users to execute your instructions, because by default your instructions are executed as a root user. The next question we have is, how do you ensure service readiness in Docker Compose? So in a typical microservices stack using Docker Compose, services like a backend app often depend on databases, messaging queues, or APIs. Now the problem is Docker Compose generally starts the services in parallel, which means the application may start before the database is ready, which can lead to connection errors or crashes. So for example, so in this case, you can see I have a database and then I have a web application, and I'm using this depends on DB, meaning what I'm telling my web app is that this particular service depends on my database. So even with depends on, Docker Compose does not wait for the DB to be ready. It only waits for the container to be running. So it does not wait for the database inside the container to be ready. It's only the container that it is waiting for. So what's the right way? So for this you can make use of health checks and wait for it, or custom wait scripts to ensure readiness. So one option you have is you can have your depends on, and then you can make use of your service health. So this will make sure that the container inside the database inside the container is ready. So the DB container will run a health check using PG is ready. So you can see there's a health check that I'm specifying. The app will wait until DB reports healthy before starting, and the depends on condition. So this one particular basically works only in Compose CLI and not in Swarm mode. So you'll have to keep that in mind. The other option you have is you can make use of wait for it or wait for scripts. So this is language agnostic and useful if health checks aren't supported or reliable. So you can basically add a shell script. So here you can see we are doing a wait. So we are waiting for the database to be ready, and then we will just update our Docker file to call that particular script. Now the third approach you can have is add retry logic in the application. Okay, so you can also build retry mechanism in code. So using exponential back off for DB connection. Now the advantage of this is it works across environments, Docker, Kubernetes, etc. It is independent of Docker Compose, and here is an example of using Python. So we are continuously retrying it, and then if nothing is working, then we are breaking it. The next question we have is, how do you safely clean up unused Docker images in production? Now over time, when you're working with your Docker or Kubernetes, Docker environments accumulate unused images, containers, volumes, and networks, which consume GBs of disk spaces. It can lead to slower deployments and may even cause system instability if shortage fills up. However, in production, blind cleanup is very dangerous, right? You must clean safely without deleting anything critical, right? So let's say we're talking about production, so it's always important that we be cautious about what we are deleting. Now there are few commands that we can use in Docker, which will help us to free up space and delete any unused components. So one of the command we have is docker system prune -a. Now this will delete all your unused images, even if the containers reference them indirectly. So you can see all the stopped containers, all the networks, all the images, all the build cache. Are you sure? Okay. The other command we have is docker volume prune. Now this will remove volumes that are not currently in use. Now this can cause data loss if apps rely on orphaned volumes. Again, you have to be very careful. The other option we have is docker rm dollar docker ps -aq. Now this will stop and delete all the containers even if they are production ones, right? So you'll have to be very careful with this, okay? And it is recommended that you don't do this. This is not the right approach. So how do you do this? So the safe approach is, first you can do this docker system df and then analyze this first. Okay, so before cleanup, always check your disk usage. Now this will show the images, the size of the images, the containers, volumes, build cache, everything, right? So what is in use, what is not in use, everything. Now if you want to clean, like in this case, you can see I have an option to reclaim close to 82% of my size. Okay, so how do you reclaim it? So you can use docker image prune, and this will remove only your dangling images. So confirm this, and this will, if there are any dangling images, like images which are corrupted or the layers are not in use, it will release those. So this will delete all of your dangling images, intermediate build layers not associated with any tag, basically which are not in used. You can also remove your containers. So we can use docker container prune, and this will remove all of your stopped containers. Okay, only the containers which are in the stopped status. Now this is safe if you're not debugging them. Then remove your unused networks. So docker network prune, and again confirm this, and this will remove any custom networks that you have created that are not connected to any containers. The default networks will remain intact. Now there are a few more options, but you have to use them with cautions, like docker volume prune. Now again, be very careful with this. If there's any data which your application depends on, then if you delete them, then your application will fail. So only run if you're sure of any unused volumes that are not storing any critical data, like your databases. Now you can also check, by running this command docker volume ls -f, and dangling is set to true. Now this will tell you, this will only list the volumes which are in the dangling state. Then if you're in production, you can think of automating this. So you can use scheduled jobs or cron scripts with proper filters to schedule them. All right. So there are a few options which are available. You can have monitoring tools in place. You can consider tools for granular cleanup as well. So there are options that are available. The next question we're going to talk about is, how does overlay network work in Swarm? So when you run containers on multiple host machines in a Swarm cluster, they need a way to talk to each other, often across different machines. And that's exactly where overlay networking comes in. It abstracts the network so services behave as if they're on the same local network, even when they're on separate nodes. So what is overlay networking? So an overlay network is a virtual network which is built on top of the host network, and this allows containers to communicate across hosts as if they are on the same LAN. Now this uses VXLAN, which is your virtual extensible LAN under the hood, and this allows inter-service and inter-node communication. This works securely by default with encryption and service discovery. So how it works in Docker Swarm is, you create a Swarm cluster with multiple nodes. You create an overlay network by running a command. So when services are attached to this network, Docker sets up a VXLAN tunnel net between the nodes. Containers get virtual IPs. DNS based service discovery is automatically handled. And then finally, Docker routes the traffic to the correct container. Now for this, it uses routing mesh and then direct communication, basically for your container to container calls inside the overlay. I'm not going to show an example, but basically for this, you'll be running a command like docker swarm init, create your network, and then you'll be starting the services. But basically, this is what your docker swarm is. The next question we have is, how do you scan images for vulnerabilities? Now, Docker images often contain OS packages, language binaries, or third-party tools, any of which may include security vulnerabilities. And if left unscanned, these vulnerabilities can lead to unauthorized access, data breaches, exploits at runtime. So, image scanning is a core part of your DevSecOps. So what exactly is image scanning? So image scanning involves analyzing the container layers for known vulnerabilities, basically your CVEs. This can be at your OS levels, packages, application dependencies, configuration files. So scanners basically compare these components against vulnerability databases like your NVD, which is your National Vulnerability Database, GitHub Security Advisors, vendor feeds like Alpine, Ubuntu, Red Hat, etc. So for this, there are multiple tools that are available in the market which you can use to scan your images. So we have tools like Trivi, which is fast, easy to use, and supports SBOM and infrastructure as code scans. Then you have Gripe, which is your CLI scanner with Cyclone DX and SYFT integration. Then you have Claire Static, which analyzes which is used in Harbor registry. Then you have Anchor, which is a full-fledged policy engine, and you can easily integrate them with your CI/CD. Then you have Docker Scout, which is your native Docker image insights, formerly known as your Docker Scan. Then you have your Sync, which focuses on developer security, and you can integrate them with your Git repos. And then finally, we have your Aqua micro scanner, which is minimal, designed for CI pipelines. Now, in our case, we will look at your Trivi as an example. But before you get started with that, you will need to install the tool first. So if you're on Ubuntu, you can simply run apt install Trivi. But if you have Trivi, you can just run this. And in my case, I have Trivi. Now, once you have your Trivi, you can start using this to scan your images. So let's say I want to, so we'll use Trivi scan, and let's say I want to scan the Nginx latest image. So Trivi, sorry, it's Trivi image. So this will scan my Nginx image and will tell me if there are any vulnerabilities with that particular image. So this will take some time, but you should be able to scan it. Now, as an example, we will build a Docker file and we will use that to check for vulnerabilities. Okay, so getting a space issue. So let me clean up. So let me delete this image. I don't want. Okay, that's fine. I think that should be enough. Let me rerun this once again. Okay, so there seems to be a space issue. So what we will do is, let's create a Docker file, and let's say I will use this as an example. Let me put this, and let's do a, sorry, so let's scan this. So trivi config dot. Now make sure to name your image as Docker file with uppercase, because this Trivi looks specifically for this one. So now here is my scan report. So Docker file, there are 3 misconfigurations. So specify at least one user command. So basically, run the instructions as a non-root user. That's one. Then use health check instruction in your Docker file, and then specify a tag in the from instruction for image alpine. So basically the latest or which version. So this is medium, this is high, and this is low vulnerability. So like this, we can use the scanning tools to scan our images and see if our image has any vulnerabilities or not. Now, some best practices for image vulnerability scanning: scan the images early. So scan during your development and not after deployment. Then scan your base images as well. So even official images like Alpine can have CVEs. So always scan them before you use them as base images. Then use minimal base images. So choose secure bases like Alpine, Scratch, or Distroless. Now this will help to reduce the attack surface and typically contain fewer packages. Then automate scanning in image registries. So if you're using ECR, then you can enable scanning in ECR as well. Then set your severity thresholds. So fail builds if high or critical vulnerabilities are found. You can do that as well. Fix and rebuild regularly. So rebuild your images frequently to get latest package updates. So you can use tools like Renovate or Dependabot to keep Docker files updated. The next question we have is, how do you manage secrets in Docker? Now, hard coding secrets or passing them insecurely can lead to data breaches. So, no hard coding of your secrets. So, you can have data breaches, you can have credential leaks, and you may also have non-compliance. So, proper secrets management is critical in production containers. So, what is a secret? So, a secret is any sensitive credential or token that should not be stored in source code, not be visible in image layers or logs, be encrypted at rest or in transit, and be access controlled, which is basically giving least privilege. So, secret management in Docker depends on environment. So, if you're using Docker Swarm, then you can make use of your Docker secret, which is native, it is encrypted, and it is built in. If you're using standalone Docker, then you can make use of environment variables, bind mounts, or third-party tools like which can be manual or semi-secure. If you're using Kubernetes, then secrets via manifests or integrations. So this uses base 64 and this is not encrypted by default. And if you're using CI/CD pipelines, then you can consider using secrets manager like GitHub Actions, GitLab CI, or secrets manager in AWS. And this will help you to secure your runtime injection. So again, I'm not going to show you an example, but you can create secrets and you can start using that in your Docker file to securely pass your secrets and never ever hard code your credentials. The next question I have is, a container keeps restarting. What's the root cause? So Docker or container runtimes in general restarts your containers based on their exit status. Like when there's a crash or there's an error, the defined restart policy, underlying resource constraints, or external dependencies failing. Now, some of the common root causes of container restarts include app crash. So in this case, the application exits due to a runtime error. Then invalid config. So environment missing or incorrect environment variables or configs can cause failure. Then port conflict. So two containers trying to bind to the same host port number. Restart policy. So loop container is set to restart on failure. So like using hyphen restart always or on failure. Then resource limits. So out of memory or CPU throttling kills the container. Then dependency failure. So external DB, API, or service is unavailable, which can cause the application to exit. Then you may have secrets missing. So your secrets or volumes are not mounted properly, which can cause boot errors. And then finally, corrupt image. So bad Docker file or broken build produces a non-startable image. So how do you troubleshoot this? You can check the container logs, look for stack traces, exception messages, missing configs, inspect restart count and status. So if you are using your container, so then you can check for this one, the status. So if your container is starting multiple times, check if it says exited or something else. So in my case, you can see it says up, but if there's a problem, this will say exited or something else. See if it says exited or restarting. Basically, describe the restart policy. So what is a restart policy that you have set for your container? So you can use this docker container inspect and then grep for restart. Okay, so you can see restart count is set to 0. So in this case, the container, if it fails, it will not try to restart it. Then check the exit code, check resource limits, run the container interactively to debug it, inspect your Docker file or CMD. So basically, check what is happening. Does it say any issues with the application itself or with the container? You can troubleshoot those things. The last question I have is, what's the difference between CMD and entry point? Now, both CMD and entry point are Docker file instructions that define the behavior of your container at runtime. However, they serve different purposes and behave differently when runtime arguments are passed to the container. So your CMD provides default arguments or commands. Entry point defines fixed command or executable. Okay, so let's see an example. So I'll show an example and hopefully that will help you understand this. So here we will use Alpine as our base image and then CMD echo hello from CMD. Let me close this. So now when I run this image, okay, so let me save this and let's first build this. So Docker build demo one. Oh, sorry, I need to give the -t here. So this will build the base image for me, and now let's run this. So Docker run demo one. So this should start. So you can see here hello from CMD. So that's my CMD. So here you can see the default output from the image. Now with your CMD instruction, it is fully overridable. That means now I can override this when I'm starting the container. So let me show this. So echo and then hello from DGR uploads, and you can see I'm able to override it. So that's your CMD instruction. You can override the instructions by command line arguments. Now, when it comes to your entry point, right? So let's go to the entry point and let me comment this, and we will use entry point. Now, with your entry point, let me pass this instruction echo, right? And let me run this. Sure. So Docker build -t, and let's say this is demo 2. So this will be the second version of the image, and now let's run this. So Docker run demo 2 and then let's say hello. Okay, so now we are basically passing the arguments to your entry point. Okay, so I can also do, let's say Docker. I can say, let's say DGR uploads. So now I'm passing arguments to my entry point instructions. So entry point is not overridable from the CLI, but only the arguments can keep changing, but I cannot override the instruction itself. So how do we use your entry point and CMD together? So what we can do is, in my Docker file, so I can have this CMD. So let me go to CMD, and then I can pass this in my CMD instruction. Okay, so now let's build this. So this will be my version 3, and let's run this. So docker run demo version 3. So you can see here now in my entry point. Okay, so this is the entry point, and I'm passing my arguments to the entry point instruction. So I can override whatever I want, and that will be passed to my entry point as an argument. So let's say I will say docker run, and let's say, okay, so you can see, so this will remain constant, this will never change, it is fixed. CMD can be used to pass the argument. So this can be your default arguments, and if you want to pass something else, you can pass that as an argument in your CMD, which is overridable. So that's basically what your CMD and entry point instructions are. So using shell form, like your CMD does not forward signals properly. So you can use them in combination. Your entry point and CMD depends on your use case. So if you really need to override your entry point at runtime, it is possible, but generally we don't do. We always use the CMD to pass the arguments to your entry point instructions. Right, so that's about the questions that I have for you. So Docker mastery, it is not just about commands, it's about real world application. So these questions will really help you to understand your Docker, get some hands-on, and help you with your interview process as well. If you found this video helpful, please like, share, and subscribe to the channel for more DevOps deep dives. Drop a comment with your toughest Docker challenge, and please share your experience of your interviews, the kind of questions that they have asked. Until then, keep learning and keep shipping. Thank you for watching, and I will see you in the next video.